Hi there, welcome to High School Maths. Today we're going to be looking at angle properties, and this is the third video in this series of angle properties, so check out the first two if you haven't already. So we're going to look today, and we're going to start off with X shapes or opposite angles. Now the key thing here is you've got two straight lines crossing over each other, and we want to use that to find the missing angles that are within the shape. And the important thing is opposite angles are always the same. So if this angle here is 70 degrees, the angle directly opposite is also 70 degrees. And that's how it works for all of these kind of X shapes. Now, once we've got those two, we can find out the remaining angles. And there's a couple of different ways you can do that. The way I find easiest is to look at this angle here and this angle here as a straight line. Okay, so essentially we're covering up and just focusing on the top part here. If that's a straight line, remember a straight line angle is 180 degrees. Then this angle will be 180 minus 70 degrees, which is 110 degrees. So this is 110 degrees in here. And if that's 110 degrees on this side, directly opposite, because it's an X shape, is also 110 degrees. And I have absolutely no idea why I can't write the number 110. There we go. And if you add them all up, it is a full turn, which is 360 degrees, and all the angles do add up to 360 degrees. So let's look at this one. Here, it's still X shapes, but there's an extra line added in, so there's an extra X. Now, we've got to be careful and make sure we are getting directly opposite when we match up the angles. So if this is 27 degrees here, then directly opposite is this one, which is 27 degrees as well. Likewise, 100 here, that's 100 degrees there. Okay, that leaves us one missing angle and the opposite angle to that one. Again, I'm going to look at the top section. So I'm going to look at this whole kind of three corners here, because that makes a perfect straight line. You can see me highlighting that with my pencil. And all three angles here have got to add up to 180, which means for this one, we've got 180 minus 100 minus 27. Oh, that's not how you do 27. 180 minus 127 would leave us 53 degrees for this angle here. And again, directly opposite, because it's this kind of X shape, is 53 degrees here. And if we added all those angles together, it should give us 360. So that's a quick way you can check that you've not made a silly mistake. And here's kind of one in context. We've got the Scotland flag here, X shape, both straight lines. This is 130 degrees, and let me just change my font color. That's 130 degrees in here as well, because it's opposite. If we look at the straight line, so if we look at this kind of top section, that's a perfect straight line. That's 130, that's going to be 50 degrees. 180 minus the 130. So 180 minus 130 is 50 degrees. So that goes in there, and directly opposite is 50 degrees as well. And again, all those four angles would add up to 360 because it's a full turn. So that's your first new angle property, that's X shapes. The next angle properties are going to be looking at parallel lines. And we've got the first angle property as F angles or corresponding angles. Now, F angles are called that because they look like F shapes. That's what you're looking for. You're looking for that shape and looking to recognize it, where you've got this parallel set of lines here. Remember, parallel lines run the exact same direction, and you denote them with a little arrow to show that they're going the same way. Here, we've got this F shape. Under this parallel line is 104 degrees, and the key feature of this corresponding angle, if this is 104 underneath the line, this is 104 underneath this line as well. We've got the slope and straight line to join those two parallel lines up. We can also find this angle here. If we just focus on the straight line part, so that's this part is a perfect straight line, that corner plus that corner makes 180 degrees. So we do 180 minus 104, that will give us this angle here, and that's 76 degrees. So again, we're getting to that process where we're building up the angles to get all the missing angles in the picture. Here, you can see the F shape can rotate. It can be hidden amongst picture, hidden somewhere in a picture or a diagram. And here we've got one that's been rotated upside down, but it's still an F shape. You're looking for those two parallel lines and a line sticking out like so here. So we've got 115 degrees, this time above the line. So above this line is also going to be 115 degrees. And we're going to do the same thing as last time. Focus on this part. You can see that that's a perfect straight line. So 180 for this part, 180 minus 115 is going to give you 65 degrees, and that makes 180 for our perfect straight line here for this section. On to the final one. This looks more like an E shape, but actually if I highlight the key points, we've got a F shape there and another F shape there. Okay, so really it's just joining up the first question and the second question into one diagram, but it makes it a little bit harder to see. Now if we focus on the first F shape, that's this one here, below this line is 101 degrees, so below this line will also be 101 degrees. Okay, now this angle here is going to be 180 minus 101, which is 79 degrees. Okay, now you might be wondering, where can I go from there? Well, actually, if you look at it, there's another F angle hidden. We've got one here. So that kind of F shape appearing again there. So that means, I'm going to take those highlights away, that if this is 79 degrees above the parallel line, this is also going to be 79 degrees. Now one of the other common properties you'll look at, more specifically later on, is parallelograms. Parallelograms have the exact opposite angles in their corners. So if this is 101 here, this will be 101 here. If this is 79 here, this is 79 here as well. And again, that's all to do with your parallel lines making this parallelogram shape here. This is 101, and this is 101. This is 79, and this is 79. Okay, so that works because these are parallelograms. They don't have to be, but you would need more information if they weren't. Now, sometimes you might have, to signify that they're parallelograms, another set of double lines, double arrows there to show that these are parallelograms. So we'll just put them in. That shows that these two lines are parallel to each other, and that does make the parallelogram. So we can use the information from F angles to build up our shape again. Let's have a look at the final new property, which is Z angles or alternate angles. I find these a little bit easier to spot. They're called alternate angles because you can see you've got this Z shape here, parallel line at the top and bottom with a line joining it up. And if this is 38 degrees, and the in between the other corner of the Z shape is also 38 degrees. No calculation required. This one's a little bit trickier. Here's our Z shape, but the 130 is outside. It's not inside the corner. It's not kind of tucked away inside like the first question was. Now, to figure out this angle, well, look at it. It makes a perfect straight line. So here, this corner plus this corner must equal 180. So 180 minus 130 leaves us 50 degrees. So that angle in here is 50 degrees. That's the one that's tucked away inside the Z corner. Here's the Z corner here. Here's the other Z corner. That's got to be 50 degrees as well. And that's how you use Z angles. Now, we're going to look at a few variations on questions and how these can all be mixed together, because that's really the complicated part. Once you've got them on their own, they're a little bit easier. But when you start to mix them together and all their angle properties, you can see they can get quite complicated. So let's kind of whiz through these. And if you need to look back through the explanations, you can do that a few times just to kind of get what's going on. First one, we've got a right angle. Okay, perfect right angle. And this means it's 90 degrees. The missing angle would be 90 take away 28 degrees. That's 62 degrees. Okay, so 62 add 28 is 90 degrees overall. And that's your right angle. This is your straight line angle, which adds to 180. So these two corners add to 180. This one is going to be 180 minus the 65 that we already have, which is 115 degrees. So this angle here, X, would be 115 degrees. Adding them together gives you 180 for your straight line angle. Here, we've got a triangle first. Okay, this is 40. What does a right angle make? 90 degrees. This one, well, the three corners of a triangle make 180. So we're going to do, for the triangle, 180 minus 40 minus 90, which leaves us 50 degrees. So this angle here is 50 degrees. If we focus on the straight line part, so that's this part here. Whoop, that's not a very straight line though. So we're focusing on this kind of part here. That's 50, that corner and that corner have to make 180 because the straight line's 180 degrees. So for this one, we're doing 180 minus the 50 degrees, and that gives us 130 degrees. So this angle here is 130 degrees. And you can see that I'm adding in each new angle as I find it. That's going to help a lot with these last two questions. So in this first question, what we've got is an isosceles triangle at the top here. So these two lines are both the same length. And what we're looking for is some features that we've covered that will help us figure out some of the missing angles. What I'm going to do is highlight the key feature, which you maybe already spotted. Remember, parallel lines, we're looking for either an F shape or a Z shape, and here we've got that kind of F shape sticking out, which means that the 70 degrees here above the parallel line is going to be the same above this parallel line here. I'm going to take the highlights away just so it's a little bit easier to see our working. So here we've figured out that this is going to be 70 degrees as well, because they're both above this parallel line in the F shape. Same as we did before, that makes a perfect straight line. So if this is 70, the two corners here have to add up to 180. That makes that 110 degrees. That's just 180 minus 70. And here, remember, this is an isosceles triangle. So if this corner at the bottom of this kind of line here, at the end of this line is 70 degrees, then the end of this line is also 70 degrees. These two angles have got to be the same. To figure out this last missing angle, angle B, we're going to do 180, because the three angles in a triangle, three corners of a triangle add up to 180, minus 70, minus 70, which leaves us with 40 degrees. So this angle in here would be 40 degrees. That's us calculated all the missing angles in that first shape. Let's go across, or this shape here. Let's go across to the final shape. And here again we've got parallel lines, but we're not looking for an F shape this time. You can see that there's our parallel lines, and if we join them up, it kind of makes that Z shape. And you can see it's a little bit rotated. It's not quite a direct Z shape, but it is a Z shape. Let's take them away. Remember, the Z shape, we're looking at the angles in between, so we're looking at this kind of angle here and this angle being the same. That'll come into play a little bit later on. Let's take away those highlights just now. So this angle and this angle are going to be the same. Now, we've got to start looking at what we can actually calculate. Okay, so here I'm going to start with A because that's the first letter in the alphabet, and this makes a perfect straight line. You can see those two corners make a perfect straight line across there. That means it's got to add up to 180. 180 minus 60 leaves us 120 degrees. So this angle in here is 120 degrees. Now if you look here, this is an X shape, which means the opposite angles are the same. So if this is 60, this is also 60 degrees. If this is 120, then directly opposite is 120. And all four of them make a 360 degree angle. A lot of information, just one little bit of working. All using your angle properties. Now let's go inside the triangle next, just work our way across. We've got two out of the three angles. We've got this one, we've got this one, and we need this missing one. That means we can figure that out by subtracting those two angles from 180. So for this part, we're doing 180, because three angles in the triangle are to 180, minus 60, minus 65. That leaves us 55 degrees for the missing angle at the top of the triangle. Now remember, this is that Z shape coming in. This angle here, the 55 degrees, was the same as this angle here. So if that's 55, then this is 55 degrees as well. And that's where that Z shape really is important, because there's no other way we could have calculated that. We've not got enough information in this section. Let's look at what we do have. You can see an X shape there. So this angle 65 is direct, two straight lines crossing over. Then that has got to be 65 as well. Okay, this one, if I highlight that, kind of emphasize this part, that makes a perfect straight line across there. See that perfect straight line? Just going to take that away. So these three angles have got to be 180. So 180 minus 65 minus 55. And that leaves us with a 60-degree angle. So this angle here is 60 degrees. Now, watch out. I know that looks like it's the opposite here, but it's not, because this isn't a perfect, remember the X shapes only work if it's perfect straight lines. So here, that angle isn't the same size as this angle. There's a few different ways we can figure out this angle here. Probably the easiest is just to look at the bottom. So remember we had a straight line here for the top. Well, we've also got a straight line for the bottom. So that's got to be 180 for those two corners as well. So 180 minus 65, which leaves us 115 degrees. So this angle is 115. Now, if we add them all together, they should add up to 360 degrees, and they do, which means that that has worked out correct. Okay, that's how you use your angle properties. There's infinite number of possibilities angles can join together. So you're looking out for your key properties, your X angles, your F angles, your Z angles, triangles, straight lines, right? All those different properties coming together and taking one angle at a time. Every time you find a new angle, it can help you with the next one. Okay, so always look out for what you can do as your next step. Don't worry about jumping straight into the final answer. Hopefully that's been useful. For other maths videos and resources, please visit highschoolmaths.co.uk, and if you liked the video, click that like button and subscribe, and please remember to share. Thanks for watching, and have a mathemagical day.